Hello, students. Hope you're doing well. Hope your semester is going good. I'm gonna record a session on the three problems which that a student has actually sent me, and those problems you can see on my screen right now. These are the problems from the section other kind of equations that may lead to quadratic or linear equations. So the first one has a radical in it, as you can see. We are not doing problems with two radicals, although they are more or like the same, a little bit more complicated. The first one has only one radical, the red one. And to do that problem, um, we need to first isolate the radical. Okay, we want to get rid of the radical. We cannot solve equation with the radical in it. So what I'm going to do is I'm going to add 2 on both the sides so that I can isolate the radical sign. So if I add 2 on both the sides, my radical stays, which is 5x plus 11, and on the right side it becomes 3x minus 11 plus 2, which is 3x minus 9. So overall now my equation changes to 5x plus 11 equals 3x minus 9. I'm going to square both sides. So that's how we can get rid of radical. Radical means to the power 1 half. And when I square it, that power 1 half and square cancels. So the next step, I'm going to square both sides to get rid of the radical. So squaring both sides, I get 5x plus 11 because radical and the square cancels. I'm not showing it here, but uh, I'm just writing 5x plus 11 equals, on the other side, you're going to square 3x minus 9 whole square. Now here you can either use a minus b whole squared, or you can FOIL it. So if I FOIL it, I get 3x minus 9, 3x minus 9, which is same as 9x square. And then I would have 2 27x, 9 times 3x, 27x, and 27x, which makes it 54x plus 81, 9, negative 9 times negative 9. And on the left side, I still have 5x plus 11. I have to make this a good looking quadratic equation. So I should have one of the sides equal 0. Since 9x square, which is the leader, which is x square is the leader right here, and 9x square is on the right side, I am going to move everything on the right side. So you have 9x square, and I'm subtracting 5x on both the sides. So if I subtract 5x on both the sides, I get a 59x here. So I get a negative 59x, and then I'm going to subtract 11 on both the sides, and I get a plus 70 here, and my left side is 0. This is a good looking quadratic equation, and I can solve it. I can factor it, but it may not be that easy to factor. Although the product we need is 630 and sum we need is negative 59. So it's hard to check because the numbers are big. I'm going to use quadratic formula instead. So if I use quadratic formula here, so let me move in this direction. So if I use my quadratic formula, I'm going to write here and then move on to the second equation. So using quadratic formula, I have minus b. So minus b is negative 54, so negative 59. So my equation is, I'm going to write it again here, 9x square minus 59x plus 70 equals 0. So minus b, so minus of minus 59, x equals, and those are my values of x, plus minus square root of b squared. So minus 59 whole squared, which will turn into positive, minus 4a is 9 and c is 70. All divided by 2 times a, which is 2 times 9, and that's 18. Now I need to simplify my square root. You can use your calculators. I have used Desmos calculator here. So if you, that's a scientific calculator for the Desmos. And as you can see, I have written the same thing in the radical 59 square, not negative 59, because negative 59 square and 59 square is the same thing. Minus 4 times 9, 10, 70, and I've taken the square root, and I'm getting a 31. So going back to my quadratic equation, this is 31. So I have two solutions. So this becomes a positive 59 here. So I have a 59 plus 31 by 18. and 59 minus 31 by 18. 59 plus 31 is 90, so 90 by 18, which is a 5. And 59 minus 31 is your 8, and 28 by 18, which is 14 by 9. So I have two solutions. Now, in the case of radical, it is really crucial to check the solutions. Why? Because now, when you are squaring an equation, you are increasing the degree of the equation. So, there are chances that you may end up with redundant solutions, more solutions. So, it's always good to check. It may be that both of these are the solutions, or it could be one of these is the solution, or neither of these is a solution. So I'm going to check, I'm going to erase some part here. So let's erase, since my equation is here, I'm going to erase this and check both of the solutions. So to check the solution, I'm going to draw a column here and check both one by one. Let's check my x equals 5 first. So for x equals 5, I plug in into either the original equation or the equation right here, which is 5x plus 11. So square root of 5 times 5 plus 11, is it equal to 3 times 5 minus 9? Or 36, 5 times 5 is 25 plus 11, so radical 36. Is it equal to 15 minus 9, 6? And that's correct, right? So 5 is a solution. So 5 is a solution. Then we have, let's check the other one. So I'm going to check x equals 14 over 9 here. So plugging in 14 over 9, I get 5 times 14 by 9 plus 11. Is it equal to 3 times 14 over 9 minus 9? That's the question, right? So 5 times 14 over 9 is 14 times 5 is 70. And so I have 70 divided by 9 plus 11. I'm going to solve this more. Equals, this 3 times 3 is 9, which is 14 over 3 minus 9. This is a negative right here. I take the common denominator 3. So this is 14 minus 27 over 3. So basically what I'm getting is I'm getting a negative number right here, right, on the right side. And when I solve a radical, I always get a, you don't even have to solve it, you always get a positive number. I mean, I can solve it, but from here itself I can say it's not a solution. It's not a solution. Even if you go further, 70 plus, if you take common denominator on the left side, 70 plus 99 is 169 over 9. So this becomes radical 169 by 9, which is 13, sorry, 9, which is 13 over 3. And it's not equal to, I think it's on the other side, you're getting negative 13 over 3. So only 5 is a solution, 14 over 9 is not a solution. Um, so that ends up, that finishes my first problem. The solution is only 5. Now for the second question, I have, let me erase this. So for the second question, I have a fourth degree equation in which it's 15x4, and I mean, this is a recording, so you can watch it again and again. Um, so the second equation is the fourth degree 15x4. I'm going to use a blue color to solve this one. Minus 13x squared plus 2. Now in these kind of equations, they mimic quadratic equations. How do they mimic? As you can see, this is a degree 4, this is a degree 2, and then a constant. In a quadratic equation, you have degree 2, degree 1, and then a constant. Now, how can you change it to a quadratic equation? Now, to change this to a quadratic equation, you can use u equals x square. I mean, a quadratic looking equation. Quadratic means degree 2. So if u is x squared, that equation can be written as 15u squared minus 13u plus 2 equals 0. Right? These are my u's. Now this is a nice looking quadratic, and I can actually factor it because the product needed here is 30 and sum is negative 13. The two numbers that qualify are negative 10, negative 3, because if product is positive, product is the product of these two terms, 15 and 2. Either both are negative or both are positive. But since sum is negative, I'm going to choose both negative, -10 and -3. So I'm going to split my middle term, 15u squared minus 10u minus 3u plus 2 equals 0. You are more than welcome to use quadratic formula if factoring is not your thing. But sometimes factoring is more efficient because it requires less computations than quadratic formula. So now I'm going to combine these two and these two terms. From the first two terms, I'm going to factor out actually not 3, 5. So I'm going to factor out 5 of u and left with 3u minus 2. From the second part, I'm going to factor out a -1, 3u minus 2 equals 0. These two must match 3u minus 2. It means you're on the right track. So 3u minus 2 and 5u minus 1, these are my two factors. From the first factor, I get u equals 2/3. And from the second factor, I get u equals 1/5. You set each of these equals 0. Now I want to find the value of x. I don't want to find the value of u. If u is this, it means x square is 2/3 or x square is 1/5, right? Now x square equals 2/3 mean x equals plus minus radical 2/3 or x equal plus minus radical 1/5. Now my lab wants the answers to be rationalized. Rationalized mean I don't want any square root or radical in the denominator. So I'm going to do plus minus radical 2, radical 3 and then multiply by a radical 3. This process is called rationalizing the denominator. Or x equals plus minus radical 1 is 1, so I'm radical 5 multiplying and dividing by the same radical 5. So this becomes x equals the first one, radical 2 times radical 3 is radical 6, all divided by 3, no more radical in the denominator, and there is a plus minus right here, and plus minus the second set of solution is radical 5 by 5. So the solution is, as you can write on my lab is plus minus radical 6 over 3 and plus minus radical 5 by 5. Okay, so this is your second solution, which is a power 4. I'm going to move on to my next one, which is the last one. And that's a rational equation. In this case, by the way, in the power 4, you don't need to check your solution because it's a fourth degree and you will have 4 solutions. Those 4 solutions could be like you have 4 solutions here. Now, those 4 solutions could be real, could be complex, could be imaginary. So, but you will end up with plus minus twice. Okay. The next one is your is the rational. For the rational, you need to know how to take common denominator, and that was one of your discussion posts as well. So the common denominator here, y minus 6 and y plus 6 are totally different factors. So if you have totally different factors, the common denominator is the multiplication of those two. An analogy will be if you have 3/5 plus 5/7. 5 and 7, if you want to add them, 5 and 7 are completely different numbers. They are not multiple of each other. So you're going to do 5 times 7, right? And then you multiply 3 with 7, you multiply this way and this way, plus 5 times 3. Same thing here. Those are completely different factors. Neither of this is a multiple of the other. So I'm going to multiply 9y times y plus 6 minus 54, I believe, times y minus 6. Now, on my lab, I believe they are doing it a different way. You may like that one. They multiply both sides by y squared minus 36, and then they cancel some of the things, which is fine too. So y plus 6 and y minus 6. So they multiply both sides by y plus 6 and y minus 6. And so they first of all they cancel y minus 6, so that's why you're left with y plus 6. Then they cancel y plus 6, you're left with y minus 6. And on the right side they cancel all of y squared minus 36, which is fine too. So on the right sides, I apologize. So on the right side, with my technique, equals 648 over y squared minus 36. Now y minus 6 and y plus 6, as this is the difference of two squares, this is nothing but y squared minus 6 squared, which is y squared minus 36. This cancels with this. So all of this, the denominators cancel. I am left with, I'm going to distribute 9y. So 9y squared plus 54y, right? Minus 54y and plus 54 times 6. Now 54 times 6 is 6, 4, 24, 324 equals 648. Okay. So I cancel 54 on both the sides, not both the sides, plus 54 and negative 54. I'm left with 9y square, and since it's a square 4 equation, it's a power 2 equation, I'm sorry. So since this is a power 2 equation, and I'm missing a y term, I can use the square root property. So I'm going to move 324 on the other side. 648 minus 324, which is again 324. And this implies y squared equals 324 by 9, which is 36. So this implies y equals plus minus 6, radical 36, which is plus minus radical 36, which is plus minus 6, because y square equals 36. Which two numbers makes 36? Square makes 36, plus 6 and minus 6. Now for the rational equation, one of the things that you must check is the solution. Since y minus 6 and y plus 6 are occurring in the denominator, clearly y cannot be 6 and y cannot be negative 6, because you don't want denominators to be 0. So whenever you have a solution, check, plug in the denominator and check it doesn't make the denominator 0. Similarly, on the right side also, 6 and minus 6 makes denominator 0. So they can't be the solution. It means the solution set in this case is empty. Empty set. So solution set is empty, nothing, or you can say no solution, like this. Okay, so that's it for me now, and please ask me if you have any other questions. Good luck for your exam. It opened today, and let me know when you're ready. I'll send you the password. Take care. Bye bye.